Alright, in exercises 7 through 10, we're going to go on from what we just talked about in the previous video, and I hope you remember two important definitions. Relative maximum is a point on a graph that is higher than the points immediately to the left or right of it. Relative minimum is a point on a graph that is lower than the points immediately to the left or right of it. And second of all, we learned that whenever we have a relative extrema, maximum or minimum, in a graph, the derivative there is always 0 or doesn't exist. And now we're going to give a name to that phenomenon, and it's going to be called a critical number. A critical number is a point on a graph where the derivative is 0 or does not exist. So we've been talking about that. We saw clearly why that is a critical point in a graph, because if a relative maximum or minimum occurs, it has to be, one of these two things has to be true. Either the derivative is 0 or it doesn't exist. So in exercises 7 through 10, we want to approximate the critical numbers of the function shown in the graph. And so let's go and do that first. The critical numbers are wherever the derivative is 0 or doesn't exist. So let's look at number 7. Well, here's a critical number right there. The derivative is 0. X equals 2 would be the critical number. Critical number is an x value. So let me add that. This is an x value. Now, in number 8, we have a special case here, which is very important. We definitely have a horizontal tangent at x equals 0. So x equals 0 is a critical number. However, notice that there is no maximum or minimum there. At x equals 0, the graph is not higher or lower than the points both to the left and to the right of it. It's higher than the points to the left, but it's lower than the points to the right. So it doesn't qualify as a maximum. So an important note here is that just because you have a critical number doesn't guarantee a relative extrema. So I note that relative extrema, max or min, always occur at critical numbers. But critical numbers do not guarantee relative extrema. And so exercise 8 is a great example of that. It's definitely a critical number. The derivative is 0 when x is 0, but it's not a maximum or a minimum, not a relative maximum or a minimum there. Alright, and number 9. So we had x equals 2, x equals 0. In number 9, we have 3 critical numbers. We have x equals 3. We have, x equals 1. Remember that a critical number is an x value. X equals 2 and x equals 3. And you can see at each of those places the derivative is either 0 or there is a sharp turn. And so each of those qualify as critical numbers. Next, in number 10, we have a horizontal tangent at x equals 2, and we have a horizontal tangent at roughly x equals 4.5. We just need to, that would be 5, sorry. So we can identify a critical number as a point on a graph where either the derivative is 0, you have a horizontal tangent, or the derivative does not exist. Now, the second thing we want to do here is determine whether the function has a relative maximum, relative minimum, an absolute maximum, an absolute minimum, or none of these at each critical number in the interval shown. Alright, so we have a new term first of all, and that is absolute extrema. Max or min. We have an absolute maximum. Well, let me say it this way. Absolute extrema are the highest for a maximum or lowest minimum points on a graph or on a given interval. So an absolute maximum is the highest point on a particular graph or on a particular interval of a graph. And an absolute minimum is the lowest of all points on a graph or on a given interval. So at x equals 2, in number 7, we can see that we both have a relative max and we also have an absolute max. In number 8, we have neither. It's neither a relative max or min or none of these. We'll just say none. There is no absolute max or absolute min there. At x equals 1, we have a relative max. We also have an absolute max. X equals 2, that is the lowest point on the graph, so we have a relative min. And we also have an absolute minimum because that's the lowest point on the graph. And it's also lower than the points immediately to the left or right of it. For x equals 3, we have a relative max and an absolute max. So a point can be both higher than the points immediately to the left or right of it. It could also be the highest point on a whole interval or on a whole graph of a function. So you could be both a relative max and an absolute max. Next, in number 10, we can see that at x equals 2, none of those is the case. We don't have a relative max or relative min, absolute max or absolute min. At x equals 5, we have a relative max, and we also have the absolute maximum on the given interval there. Alright, so hopefully that's clear. So what have we learned in this video? A critical number. It's a point on a graph where the derivative is 0 or does not exist. And we can usually identify them by sight. Those are places where we have sharp turns. Not only sharp turns, we could also have vertical tangents where the derivative won't exist. So a critical point is a point where the derivative is 0 or doesn't exist. Relative extrema always occur at critical numbers. However, just having a critical number does not guarantee you relative extrema. This is very important. And a new definition, absolute extrema are the highest of all points on a graph or an interval, and the relative minimum is the lowest of all points on a graph or a given interval. We'll go on to the next set of exercises in the next video.